Welcome back. Now we are going to look at an important idea in thermodynamics, that of reversibility. We are going to define what is meant by a reversible process. The idea is abstract, but a very important one in thermodynamics. Let us consider a situation where we have two systems, say A and B. They undergo some interaction I, maybe work, maybe heat, maybe some combination. System A changes its state from A1 to A2 and system B changes its state from B1 to B2. And let us say, just for illustration, that A and B together during this process form an isolated system. That means there is no third system involved when A and B are interacting with each other like this. Now consider a process involving the same two systems where we have A and we have B, but the process is such that A now goes from A2 to A1, back to A1. B goes from B2 back to B1, and all interactions are also inverted or reversed, sort of a mirror image process in time or a reverse process. And this reversal is such that if this process is executed and then the second process is executed, everything returns to its original state. That means if this process is possible, this process is also possible, and the combination is such, let me call this process 1 and let me call this process 2. Suppose we have process 1 followed by process 2, both are possible, then the net result should be absolutely no change in A or B, because both are back at the state A1, and of course no change in any other system. Of course, in this case, since we assumed these two systems are isolated, we precluded the existence of any other system which could get involved into this. If this happens, that there is no change, and that means this combination, process 1 followed by process 2, or even process 2 followed by process 1, leaves no trace of history, in which case these processes are known as reversible processes. Both process 1 and process 2 will be called reversible processes, because whatever they do can be reversed or retracted or traced back by executing the process in the other direction. Not only are the original states retrieved by reversing the process, but all interactions in all detail will be retraced, leaving absolutely no history, no trace. So if you look at a pair of systems, say A and B, and if they execute a reversible process, say process 1, and then they execute the reversed process, process 2, they come back to their original state, and then we look at them, we have no way of making out whether process 1 and process 2 took place or not, or whether the two systems always remained at their original state. No hint remains, no history remains. Now we know that such reversible processes do not exist in the real world. Any process executed leaves some trace somewhere. There is no process in the real world which is reversible. Then why are we looking at reversible processes? We are looking at reversible processes because reversible processes are thermodynamically ideal processes, as we will see why when we prove Carnot theorem. They are thermodynamically ideal processes but we cannot have them in practice. We can think about them. So, these are like Einstein's thought experiments. These are processes which we call thought processes. We can think about them, but we can never implement them in practice. Thank you.